Good morning to one and all listeners. Welcome to our INVENTOR project. Our team members was Gajapati, Roshini, and Surya. And our team ID was PNT 2022 TMID 30125. And our SPOC was Dr. V. Kumar, and mentor was Mr. R. Shivaguru. Then we can see our domain. And next, our domain was Internet of Things, and the use case was real-time river water quality monitoring and control system. And you can see our problem statement. In our use case, there are many problem statements contained. In major three, first one is as a farmer uses the fertilizer in the formula, the fertilizer and the pesticides are washed as form waste due to rain and get sedimented in rivers and lakes. The second problem statement is this process of eutrophication ends when the algae die and get composed by the bacteria present in the water. That is use the oxygen present in the water and decompose the algae. The third problem statement was it changes affect both the land and the marine animals. Leaves depend on the soil bodies. Next, we can see the existing problem of our users. The first existing problem was the number of diseases caused by waterborne microorganisms in today. In India, there is a alarming rate and has become a critical issue, which hinders the growth of population and is affecting the effective workers. The second existing problem, no effective measures have been taken with respect to the quality control of water source. The third existing problem was water monitoring system identify the reason for its growth, the amount of population to the water source in the city. Next, we can see the proposed solution of our use case. The first proposed solution of our use case was smart system to monitor the components and transmit the data without any error. The second one is set as a threshold for each component to identify the form or safe and notify all instances of form by 24/7 with rechargeable battery system. The third one is all the characteristics of water regarding should be noted and the created value. It can be used to predict the cause of the problem and provide a required solution. Next, we can see the performance metrics. These are the performance metrics chart for NFT non-functional testing detailed test plan. The first one is water monitoring web user interface. The NFT test approach phase. The assumption depending risk app crash developer team site out. The approval sign off approved. The second one same water monitoring web user interface. The NFT test approach load. The assumption dependency risk server crash developer team server down. The approval sign off approved. Next, we can see the future scope of our use case. The first future scope of our use case, in this project, there is a still might be helpful to solve many issues related to river water monitoring. The second one of the future scope is, in spite of the reason, the product can be even upgraded. The product upgraded means, and it can be added many features to our product, and it can be help to the people to help monitoring monitor of the water body, and it can also maybe upgraded from new features. Next, we can see the conclusion of our use case. First one is monitoring of turbidity, pH, and temperature of water. Make use of water detection sensor with the unique advantages and the existing GSM network. The second one is the need to monitor these values of water arrays with the risk cost due to the current water quality and the standard of water available for drinking, domestic, and household purpose. The third one is monitoring of turbidity, pH, and the temperature of water. Make use of the water detection sensor. The unique advantages and the existing GSM network. Next, we can see the technical architecture of our use case. This is the technical architecture of our use case. We can have two resource IoT device and a Python code random data. In these two devices, they are interconnected with IBM Plus and IoT platform. It can be sent to send the data to the IBM platform. The IBM platform was uh, creating the device and storing the data for by IoT device. The IBM Action platform was connected with Node-RED. The Node-RED was receiving the data and alerting the message to people for to drinking avoid drinking impurity water. The Node-RED was connected with the web user interface. The web user interface was connected with the post SMS and user. The post SMS was uh, the post SMS was sending the SMS to quickly to people and user also it can be collecting the message. These are the technical architecture of our use case. Next, we can see our implementation part of our project. First one is MicroPython MQTT together. This is the first implementation of our use case. See, we can generate with the Python code. It will be connected to the sensor and the register, and it also can be connected with DHT22 pin number 15, and it can be connected to Wi-Fi and the Ethernet. If Wi-Fi and Ethernet will be connected, the data and the message will receive quickly and fastly. And the parameters also will be considered. We will start the simulation. The dashboard will be open. We'll see all the parameters and the data will be shown. Then connecting to Wi-Fi can be reporting to wowki weather. See humidity and temperature. When the sensor was linked, the information will be visible like this. These are the simulation these are the simulation part. Next, we can go to the IBM Action platform. IBM Action platform, when the device simulator is on, all the device ID will be details will show, and we can create the board like this. This is a line graph. The waves are it's a line graph, and the waves are going like this. To calculate the amount of pH and turbidity, then to calculate the weather monitoring. See another weather monitoring also. It's also a line chart. Then we can see the next we can see the MIT app inverter. The MIT app inverter was designed by mobile user interface or mobile phone, and we can enter the details like this, and we can set the non-visible components like web 1, button 1 and button 2. It can be connected by the web 1 and the web 2. When webs are connected with the mobile phone, the information easily reached and stored into the mobile phone. When these are the MIT of the inverter, these are the blocks to create the MIT of inverter. When the block was created, the MIT of inverter was to receive the message. Thank you.